All right, so before you begin the notes today, make sure you click on the agenda first and you watch the YouTube video that was created by Numberphile, which is a pretty good resource on YouTube. And it's a really good video that it will explain to you E by someone else, by a mathematician. And it kind of goes through some of this information just in a little bit clearer of a way. So before you take these notes, I think it's like an 8-minute video. Watch that video. You'll see what E is, and then this set of notes will reinforce what E is. So E is a constant, and I know that you've heard of pi. Pi is constant, right? 3.14. So in early mathematical experiences, you learned about 0 and 1. Later, the number pi was introduced for circumference and area of circles. For most students, pi is one of the first examples of an irrational number that they learn. As you advance in your mathematics career, you eventually learn that there are complex numbers that have imaginary components. At this point, the number I is introduced. By your sophomore or junior year, most students know 4 or 5 of the very important numbers in mathematics. So according to Dr. Lloyd, the 5 very important numbers in mathematics he has on his license plate are 0, 1, pi, I, and E. So there's an equation that you may encounter in advanced mathematics that uses all 5 of these numbers, which is here. E to the I pi times 0 is equal to 1, or E to the I pi plus 1 equals 0. So that's just kind of for interest. But so what is E? So what you looked at in the Numberphile video was basically doing just this. So E is the number 1 plus 1 over n to the nth power as n approaches infinity. So if n is like 1,000 or 1,000,000. E is also the base of the natural log, and we're going to learn about logs pretty soon when we're back face to face. E is used in many situations, especially compound interest. So we're going to look at compound interest too. So we're going to look at a few early values. So when n is a smaller number, and we're going to approximate E to the nearest hundredth. And Numberphile already did this kind of example for you. So what I'm going to do is I'm going to actually generate this table on my graphing calculator. So I'm putting 1 plus 1 over x in my y equals menu, and I'm going to figure it out for all these different values of, n over here. So 1, 2, 5, 10, 100, and 1,000. So basically I'm adding 1 to these values, right? Because this was the 1 over n column. I'm just adding 1 to these columns. So actually, I don't even need to use my table. I'm just adding 1 to this column, right? So 1 plus 1 would be 2. 1 plus a half would be 1.5. 1 plus 0.2, 1.2. 1 plus 0.1 is 1.1. 1 plus 0.01 is 1.01. 1 plus 0.001 is 1.001. So I just added 1 to each of those. So now what I'm going to do is I'm going to raise that number to the nth power. So 2, right? That's this inside part. 2 to the first power is just 2. So now I'm going to do 1.5 squared, 1.2 to the fifth. So 1.5 squared, 2.25. 1.2 raised to the fifth, 2.488. What about 1.1 raised to the 10th? Is 2.59. What about 1.01 raised to the 100th power? 2.70. What about 1.001 raised to the 1,000th power? 1.001 raised to the 1,000th power, 2.72. So E is irrational, so it's non-repeating decimal. let's just try to find e on our calculator. So if you notice, pi is above that exponent key, e is above the divided by sign, and there's actually an e to the x key over here over natural log. So if you need to do a power of e, you can use that button. But if I just want e, I can go second divided by sign, 2.718281828, and it keeps alternating. And there's other numbers that come after that. So 2.72 was a pretty good estimate. So I'm just going to write down what it says in my calculator, 2.718281828, right? And it keeps going. It's irrational. So it says, by the way, E is not a letter in Einstein's equation for relativity, like E equals mc squared. It's not the symbol for electronic, like email, ebooks, e-trade. E is referred to as Euler's number. So you heard about that in the number file video. And it's unclear whether Euler used E to name it after himself or just the next constant he had yet to use. So let's try these together. So E squared to the nearest hundredth. So second e on your calculator, raise that to the second power. So let's round that 7.39 if it's the nearest hundredth, 7.39. What about e to the negative first? So second e raised to the negative first. You should try this on your calculator to make sure you know how to do it on your calculator. 0.37. So what if I want to graph e to the x? Well, I know based on these two values up here, basically all my key points. So isn't anything, this is going to be between 2 to the x and 3 to the x in steepness, right? This is 2.7 to the x. So if I'm at e to the x, when x is 0, what's anything to the 0 power? 1, right? So I can graph 0, 1. I already know that e to the first power is 2.7, so 1, 2.7. I already know that e squared from my calculation up here is about 7.39, so 2, 7.39. I know e to the negative first is 0.37. So there's e to the x, right? It behaves just like our other rational functions. It has an asymptote at y equals 0. It's a steepness that's between 2 to the x and 3 to the x. All right, well, what happens if I do e to the negative x power? Doesn't it just take this set of points and flip it over the y-axis? So I'm still going to go through 0, 0, negative 1, 2.7, negative 2, 7.39, and 1, 0.37. So that's coming down like this. Dotted line at y equals 0. And the last one, e to the e plus x plus 2 is shifting us left 2. So I'm going to take this graph and shift all of my points left 2. So instead of 0, 1, I'm at negative 2, 1. Instead of at 1, 2.7, I'm at negative 1, 2.7. Instead of 2, 7.4, I'm at 0, 7.4. And then 0.37 is pretty small. So there's my function that's been shifted left 2, still has an asymptote at y equals 0. So the last thing I'd like you to do is answer this question. What 2 interesting facts about the graph of f of x equals e to the x were stated in the video that make the graph of f of x equals e to the x and the constant e very important in calculus? So I'd like you to add that down below here and then submit this guided practice page for your work for today.